Okay, so now let's look at this problem. It said that use the shell method to find the volume of the solid generated by revolving the sheet region about the indicated axis. So problem 13 said that about the y-axis. So this is the problem. This is the y-axis, okay. So if you do the revolving, you're going to get something like this, right? So the big difference between shell and washer is like when you have a shell here, you actually is trying to figure out, okay, what is the volume of this shell? Okay, so once you find the representation of this shell, and then you are all good to go. And the other important part I would like to introduce is, when you use the shell method, the rotation axis is y-axis, and then we constructed the shell. That integral is gonna be with respect to the x-axis. Okay, in other words, so you are rotating with respect to y. When you're trying to using the shell method, and then you're gonna have an integral involved with dx. Okay, so that's the first thing you need to know. And also, our x is from 0 to 5, so that's very easy to drive. So once we got that, and also this dx, which is the thickness of this shell. So we need two more things to make sure. The first thing is we need to figure out the circumference, okay, of the top. And then we also need to figure out the height, okay. So the height in this problem here, it's easy to get, which is square root of 5x, okay, so that's the height. And then the radius, as you can see there, which is exactly x, okay, which is x. So the circumference, so that's the radius. So the circumference, which is 2 pi times the radius, okay. So we have the circumference, 2 pi times x, times square root of 5x here, and then dx. So basically, this problem is asking you to solve for this integral, okay. So now, once we got that, things become pretty straightforward. So let's see how do we do that. So we have 0 to 5, so we have 2 pi x times square root of 5x, right? And then dx. So what we can do here is we can factor the 2 pi times square root of 5 out from 0 to 5. And then what left here is x times square root of x, right? dx, because I factor square root of 5 out. And more we can do is we can rewrite this into x to the power of 3/2, right? dx, because x square root of x can be rewritten as x to the power half. So right now, this problem should be very easy to solve. That is x to the power of 3/2 plus 1 over 3/2 plus 1. And then, don't forget, it's from 0 to 5, okay? So now, we got 2 pi square root of 5. And then on the top, it's going to be 5 to the power of 5 over 2, because 3/2 plus 1 is 5 over 2, and over 5 over 2, okay? And then minus 0, okay? So basically, this problem is trying to simplify this process. So let's see, is there something we can simplify? First of all, we can have 2 pi square root of 5 times 2 times 5. So 5 over 2 can be written as 2 plus 1 over 2, right? So in other words, 5, so it can be written as 5 squared times 5 to the power half. And then over 5, okay, because I flipped this to up. And then, let's see what we get. We can have 2 pi square root of 5, right, times 2 times 25, times, this is actually also square root of 5, and then over 5, right, over 5. So now 2 times 2 is 4, right? Square root of 5 times square root of 5 is 5, and then over 5 is cancelled. So in other words, this is gone. So it turns out what we get is 100 pi. Okay, so let's go back to look at, do we have 100 pi here, the answer? Well, the answer is yes, sir, we got it. So it's 100 pi. Now, let's move on to look at number 14. So again, this is still, this is the region, and then it asks us to do the rotation about the y-axis. It's pretty much it's the same structure, and then the height, which is given 3x minus x squared. You know, because again, when you're trying to form one shell, you need to find the height, you need to find the radius, you need to find the thickness, which is in this case is dx. So the height is this, the radius is x. So our function is going to be from 0 to 3, 2 pi times x give us the circumference, times the height, right, and then times the thickness. That will give us the volume of the shell, times the height, which is 3x minus x squared, and then dx. Okay, so that's how to form this. And then the problem becomes, again, we're trying to solve this integral, which is from 0 to 3, 2 pi x, 3x minus x squared dx, right? We can factor this 2x out, so that is 2 pi, 0 to 3. X times 3x is 3x squared, x times x squared, it's x cubed dx, right? So we got 2 pi, let me do that. So it's x cubed, right, minus x to the power 4 over 4, from 0 to 3, okay? So that you can do 2 pi, this is 3 cubed minus 3 to the power 4 over 4. So we got 2 pi. This is going to become into 27. This is actually it's 81 over 4. Okay, 81 over 4. Okay, so now let's try to do. So 27 times 4 give us is 108. Okay, so now we got it's 2 pi times actually it's 27 over 4. So it turns out we got is 27 pi over 2. Okay, so that's the answer. Let's try to see if we got the answer is correct. So do we have 27 pi over 2? The answer is yes. Okay, so we got this. All right, so now let's move on to number 15. So again, use the shell to figure out revolving about the x-axis. So this one, let's see. We have y equals 2x, this one. Y equals 0, which is the x-axis. X equals 3, which is here. So this is the region, right? So this is y equals 2x. So revolve about the x-axis. So we're doing revolving about this, okay. And then, okay. So you're gonna have a shell in this way. So, the answer for here is gonna be something dy, okay. because the thickness here is in terms of y. So when x equals 3, y gonna become into 6. This is 6. This point is 3, 6. So we got that our interval is from 0 to 6. Okay. Excuse me. Our height, our radius for this shell is gonna be y, right? So it's gonna have 2 pi y. That's the circumference. And then this part you need to be very careful. That is, this is the height, right? This is the height. But you can see that the height, actually it's the distance from this point to this point. So how do we calculate that? Now, if we connected this dotted line here, do you agree that this dotted line, actually this part is x, right? And then adding the height, it gives us, it's a 3 because this is a rectangular here. This is 3. So in other words, the height, which is going to be 3 minus x. But go back to what we have here. Our integral is about y. So we need to solve x in terms of y. That gives us is x equals y over 2. Okay, so we substitute that part. So our height is exactly 3 minus y over 2. So that's 3 minus y over 2. So that's solve the set up the volume integral. So the next one is we can evaluate this integral. How do we do that? Well, so since I have over 2, I have a 2 here. What I can do is I can factor this 2 inside of this parenthesis. So it's pi y 6 minus y, right? dy here. And then we have pi times 0 to 6. Y times 6 is 6y. Y times y is y squared. And then dy. And then, so it's pi. This part is going to become into 3y squared minus y squared over 3 from 0 to 6, right? From 0 to 6. So we can evaluate this. So it's pi times 3 times 6 squared minus 6 cubed over 3. And it turns out, believe it or not, this is 3 times 6 squared, right? This is 6 cubed over 3. So let me put it here. 6 cubed over 3 can be written as 6 times 6 squared over 3. So which is the 2 times 6 squared. So this is minus 2 times 6 squared. And then turns out, the inside of the bracket is just a 6 squared. That's 36 times pi. We got 36 pi here. Okay, so that's number 15. So if we check, do we have a 36 pi here? The answer is yes. So we got this is number 15. Okay. Next, 2 parts. The set up the integral here. So the length of curve formula is given by from a to b square root of 1 plus the derivative squared dx. Okay. So in this problem, y equals x cubed, so y prime, which is 8x to the power 7. And then, so if we follow that, that integral is going to be from 0 to 1, 1 plus 8x to the power 7 squared dx. And this part actually it's a 64x to the power of 14, right? So you can figure out the correct answer is going to be B. Okay, so that's number 16. Let's try to see if we have some other examples. Oh, we got one. So it's a similar things, okay? So for here, you can see that x equals y squared plus 6y. This part, y is from 0 to 6. So the derivative with respect to y, x prime, is going to become into 2y plus 6, right? And then that is dx dy. So the derivative for here is going to be the length of the curve is from 0 to 6. 1 plus 2y plus 6 squared dy. if you expand this is 4y squared plus 24y plus 36, right? And then plus a 1 here. And then put it together. So this part is going to become into 37. And then if we look at it, do we have a 37 here? The answer is yes. So that's the answer is B. Okay, so that's the end. So thank you for watching.